Assalamualaikum. 5.3.7 Electrophilic addition reaction of alkenes. So here we are going to learn about the mechanism on how the reactions involved in alkenes. So for the overall reaction, electrophilic addition. Okay, addition reaction is the reaction where an unsaturated molecules become saturated by the addition of a molecule across a bond, a double bond. So this is an alkene. So it's the double bond here. You're going to add in X and Y. So example, XY to HCl. So you want to include H and Cl in this alkene structure. So you will get an alkene with X dan Y dalam struktur dia. Alkenes are relatively more reactive than alkenes. The electron-rich double bond is the active site or the functional group of the molecule. Okay, these are the types of electrophilic addition of your alkene. So we covered 5 reactions on the electrophilic addition. So the first one is catalytic hydrogenation reduction, where from alkene you add in 2 hydrogen to make it an alkane. Halogenation in inert solvent. Okay, halogenation, there are 2 types of halogenations, which is alkene halo, maksudnya kamu akan include halogen dalam alkene, halogenation. So there are 2 conditions, it's either in inert solvent or in water. It will give a different products for both of the reactions. So for alkene in inert solvent, you add in any halogens, so it will convert it into dihaloalkene. Tapi kalau halogenation in water, alkene jumpa dengan any halogens, so you will produce a halohydrin. Halo tu ialah halogen. It means halogen. Halo is your halogen. Halogen. Hydrin is OH. So maksudnya dalam struktur kamu akan ada halogen dan satu lagi akan ada OH kat situ. So the fourth one, hydrohalogenation. So kamu ada hydro means hydrogen. Hydrogen and halogenation. So you're adding a halogen and a H in your structure. H dengan X dekat situ. So it will make an haloalkene. So the final one is hydration. Alkene tambah dengan air, dia akan convert jadi alkohol. So this is the summary of your reaction. Alkene jumpa dengan hydrogen, so you will make you will open the double bond to make it into a single bond dengan dua-dua H akan masuk dalam alkene tadi tu. So hydrogenation atau reduction. So double bond jumpa dengan bromine, kamu punya halogen in inert solvent, there are 2 conditions tadi kan, inert solvent and water. So in inert solvent you are making a dihaloalkene. Dihaloalkene. So this is your product when you add in halogen in an inert solvent. Tapi kalau alkane, halogen in water, so you will convert it into a halohydrin. So ada halogen, your X, dengan hydrin, your OH. So you have both, your X, halogen, and your OH. So this is a halohydrin if you make a halogenation in water. So the third one, the fourth one. So the fourth one is between alkene jumpa dengan HCl. So dia akan dapat hydrohalogenation. Hydro which is your H, halogen which is your X. So kamu masukkan X dengan H dalam struktur alkene untuk jadi hydrohalogenation. So the fifth one, alkene dalam water dia akan convert jadi alkohol. The process name is hydration. Okay, so this is the general mechanism of a of the electrophilic addition. Electrophilic addition maksudnya kamu memasukkan yang ada charge positif ke dalam alkene kamu. So the first step, pi electrons from alkene acts as a nucleophile. So ini kan penuh dengan elektron kat sini. So when it has extra electrons, so dia akan act as a nucleophile. So double bond ni akan act as a nucleophile dan ingat negatif akan pergi serang positif. At any reaction, negatif kena jumpa dengan negatif kena serang positif. So this is full of electrons. So it is electron banyak elektron lah. So it's full of electrons. So it will attack your electrophilic. Itu kenapa dia panggil electrophilic addition. Sebab electrophilic akan masuk ke dalam molekul tu. So the first one, electrophilic akan masuk dekat double bond ni. And it will make the other one, kan dia dah buka kat sini satu, dia dah tak ada kat sini, dia naik kat sini satu. So bila sini dah cukup, the first carbon, ni carbon satu, ni carbon dua. So the first carbon is already octet when you break up the bond. So there is extra bond kat sini, so 1, 2, 3, 4. But the carbon 2 has not completed. The electron is not completed. It have a division of 2 electrons kat situ. Dia hanya ada 6 elektron kat sini. Itu menyebabkan dia ada charge positif kat situ. So the second step, nucleophile. Remember you still have another part of your equation tu. Kamu mesti ada contohnya ni lah. Ini ialah H. Your E plus is H. Your nucleophile is negative. Cl negative. So you still have Cl negative in your reaction. So Cl negative ni negatif jumpa positif akan serang negatif. Negatif akan serang positif. So the nucleophile will attack your carbocation. Okay, sorry. This is what we call as a carbocation. Carbo is a carbon, short form of carbon. Cation is a charge positive. So your nucleophile will attack your carbocation. So this is your final product of your reaction. Okay. Electrophilic addition, summary of mechanism. The first step, yang first step tadi, reach a carbocation intermediate. One new bond is formed. So yang tadi tu, C, E, H, yang ni ada E tadi. Electrophile dah masuk, yang ni ada H, ini ada positif. So ini maksudnya a new bond is formed. Satu bond terbuka yang tadi ni daripada double bond. So a new bond is formed and a carbocation kat sini. So the second step completes the reaction by forming a second bond. Okay, second bond kat sini lah dia akan form kat sini nanti. Again, this is the interplay between positively charged electrophilic and negatively charged nucleophilic species. So the first reaction, catalytic hydrogenation, reduction of alkenes. So the first step, addition of hydrogen to a double bond to yield an alkene in the presence of catalyst, transition metals catalyst. So this is a must, the catalyst. Sama ada nak guna nickel, PT platinum atau PD. Okay, PD. Okay, so you add in 2 hydrogen into this alkene. So just masukkan je lah. So double bond ni akan terbuka. So dia akan satu akan masuk sini, satu akan masuk sini. Hydrogen. So settle. Reaction ni tak ada masalah. So they just fill in the blank saja. Double bond terbuka, dua-dua hydrogen akan masuk kat situ. Replace the double bond. So checkpoint, wait for the answer. Okay, halogenation. The first halogenation in an inert solvent. So kalau dalam inert solvent dia akan menghasilkan dihaloalkane. So ini akan hasilkan dihaloalkane. alkene. Okay. Different condition will make a different products. So unlike alkene, alkene can react with halogen at room temperature and dark condition. So kalau alkene, ni alkene, dia boleh buat dalam room dengan dark condition. Kalau alkene, what is the process of alkene converted into haloalkene? Free radical reaction. Free radical reaction. Satu saja reaction yang terlibat dalam alkene. This is the only reaction that involved in your alkene. So in this reaction, you has to have UV dekat situ as the main source for it to convert. UV wajib ada dengan light. So kat sini untuk alkene tanpa light pun dia boleh buat reaction tu. That's the difference between alkene dengan alkene kat sini. So this is your alkene, a double bond here. So in an inert solvent, just add in your bromine, both side. So dia akan convert lah dihaloalkene. So this reaction is simple. Masukkan je. Anywhere that is empty. Okay, reaction ni hanya boleh involve chlorine dengan bromine sahaja. Sebab dia cakap apa? Fluorine is too reactive, iodine tak boleh nak masuk. Okay, so this is your inert solvent. Okay, this is types of your inert solvent is either tetrachloromethane ataupun dichloromethane ni inert solvent ni. So maksudnya solvent ni tak react in your reaction. So just remember in your halogenation in inert solvent, so bromine akan masuk dua-dua side, mana-mana yang kosong double bond akan terbuka. Okay, second part of your halogenation in water, dia akan menghasilkan halohydrin. Halo is your X, hydrin is your OH, alcohol. So alkene can react with aqueous halogen, chlorine atau bromine, produce halohydrin. Halohydrin is an alcohol with a halogen on the adjacent carbon atom. Adjacent tu yang berdekatan, jiran dia. So this is your alkene. So alkene masuk dengan halogen dengan water dekat situ sebab in water. This is the condition of the reaction. So alkene dia akan convert jadi halohydrin. So what is the mechanism behind this reaction? Okay, in water, chlorine dissolve in form of HCl dengan HOCl. Bromine pun akan convert jadi HCl dengan HOBr. So this is conversion. Your X tadi jumpa water, solvent tadi. Lepas tu dia akan jadi HOBr dengan HBr. So HBr ni, okay, yang ni yang akan masuk dalam reaction nanti. Ni. OH dengan Br. Okay, OH akan masuk ke sini, Br akan masuk ke sini. Macam mana kita tahu which carbon mana dia akan masuk? Dia akan serang ke carbon mana? Dia akan duduk ke carbon mana? There's a rule for it. Okay, halogenation for unsymmetrical alkene, 3-methylbutene. The electrophile Cl ataupun Br adds to the least substituted carbon. Manakala OH tadi to more substituted carbon. So how do we want to know? OH akan masuk mana, Br akan masuk mana? So this is the syarat. So it says that Br akan masuk kepada less substituted. Substituted maksudnya alkyl. Okay, contohnya ni, double bond ada dekat sini. Ini karbon 1, karbon 2, karbon 3. So dia cakap Br akan masuk kepada karbon yang sikit alkyl group dia. So ni karbon ni attach kepada sini saja. Yang ni attach kepada 3 karbon yang lain. Ada 2 karbon kat sini yang ada substitution. So Br akan pergi kepada karbon yang sikit. OH akan pergi to more substituted OH. Carbon with more substituted OH akan attach kat dia. So OH akan berada di sini, Br akan berada di sini nanti as the final product. Okay, this will be discussed during the class. Checkpoint 13. Okay, the fourth reaction, hydro is hydrogen, halogenation, your X. So you want to add in HX in an alkene. So alkene reacts with hydrogen halides to form alkyl halides, haloalkenes. So this is your ethane. Masuk dengan HBr, dia akan jadi bromoethane, which is your haloalkene. Okay, relative reactivity of HX towards alkenes increase in order of, so yang ni yang paling reactive. Reaction of unsymmetrical alkene with HX follows Markovnikov rules. Markovnikov's rule. Okay, this is a rule that been introduced by Markovnikov, geometry Markovnikov. Okay, so macam mana kita nak tahu apa masuk kepada apa? Kita simply nak cakap ke, okay, BR kita letak kat kanan ke atau BR letak kat kiri? There's a rule been introduced by Markovnikov. Okay, unsymmetrical alkenes such as 2-methylbutene reacts with HBr to produce 2-bromo-2-methylbutene. So let's say this is your original, this is your starting material of your alkene. So dia cakap 2-methylbutene. Ni karbon 1, karbon 2, karbon 3, karbon 4. So ni 2-butyl, ni 1-butene. Okay. So this is your starting material. Kamu nak masukkan HBr, kamu nak buat proses hydrohalogenation. So how do you want to know H tu akan masuk kepada karbon 1 ataupun H akan masuk kepada karbon 2? So which to which? Okay, kalau kita tengok kat sini, kita ada dua produk kat sini. 2-bromo, maksudnya hydrogen tu masuk dekat karbon yang pertama. Yang kedua pula 1-bromo. Hydrogen pula berada di karbon yang kedua. Sebab bromo dekat 1, ni karbon 1, yang ni bromo dekat karbon 2. So this is 2-bromo. Okay, how do you know? Kenapa yang ni jadi major product and this is a minor product? Okay, this reaction is a regioselective when only one of two or more possible orientations of addition occurs. So apa maksud regioselective? Okay, regioselective form positional isomer. Okay, positional isomer tu apa? Positional isomer ialah bila kamu punya functional group tu boleh berubah-ubah. Isomer dia boleh berada pada karbon ke berapa. Perubahan dia. That is what positional isomer is. So later on, there's another term, stereoisomer. So form stereoisomer over another. So this is how you want to determine H tu akan masuk mana, BR akan masuk mana. Belum lagi sebab Markovnikov tak keluar lagi. Okay, example. This is an example of your hydrohalogenation process reaction. So kalau kamu tengok dekat sini, CH double bond kat sini. So bila pandang kalau simplifykan compound ni, so dia akan jadi H2 CH double bond C CH2 CH3. So this another bond, another substitution kat sini. So this is your simplification. You want to add in your H dengan Br. So mana masuk mana? H ni akan masuk dekat karbon 1, 2, 3, kat karbon 1 ataupun karbon 2. Yang paling penting, you have to look at your double bond. Double bond yang akan mengisi ruang nanti. H akan masuk dekat mana? It's either in carbon at carbon 1 or at carbon 2. So how do you know which is which? So the rule says, the Markovnikov says, H ni akan masuk kepada karbon yang banyak H. So karbon 1 ada 2H, karbon 2 tak ada H langsung. So H akan masuk kepada karbon 1. That's why kat sini karbon 1 kamu H akan masuk kat sini dan Br akan masuk dekat carbon 2. So the same goes here. The second example of your cyclic compound. So this is your cyclohexene. Okay, so cyclohexene kamu HBr nak masuk. So look at the double bond. Tengok attachment of your two carbons kat double bond tu. So this is your carbon 1, this is your carbon 2. Tengok carbon 1, there is no H attached directly to your carbon 1. But in carbon 2, you have an H here. So H ni goes to the carbon with more H kat situ. So H ni akan attach kepada carbon 2, Br ni akan attach kepada carbon 1. So this is your final product of hydrohalogenation. Okay. Now only Markovnikov rules. Hydrohalogenation of alkene governs by Markovnikov's rule. This result has become known as Markovnikov's rule. When unsymmetrical alkene reacts with the hydrogen halide, the hydrogen adds to the carbon that has a greater number of hydrogens. So H daripada HX tu, H ni akan masuk kepada carbon yang banyak hydrogen. And the halogen to the carbon of the alkene with fewer number of hydrogen substituents. So rich gets richer. So dah lah banyak H. Lepas tu H ditambah lagi dalam struktur tu. So H ni akan ditambah kepada carbon yang banyak H lagi. Okay, Markovnikov rules lagi. When adding HX to a double bond, the hydrogen of HX goes to the carbon which already has the most hydrogen. So contohnya kat sini, this is your C. Okay, this is your double bond. So this is C1, C2. Ini yang paling penting antara C tu. So C1 kamu, there's no hydrogen attached directly to your carbon 1. Whereas for your carbon 2, you have 2 hydrogen there. So hydrogen ni akan pergi cari carbon yang banyak hydrogen. So this hydrogen will go to your carbon 2. Sebab carbon 2 ada 2 hydrogen, carbon 1 tak ada hydrogen langsung. So your Cl will go to your carbon 1. So conversely, the anion X adds to the most highly substituted carbon, the carbon with most alkyl groups attached. Okay. In another way, okay, when you relate H ni, HX ni, H akan pergi kepada most hydrogen dan carbon tu. Yang X ni pula akan pergi kepada carbon with most alkyl group attached. They are two, not definition lah, but it's a supplement each other. H akan pergi kepada carbon yang banyak H. X ni akan pergi kepada yang banyak substitution carbon, alkyl groups. Okay. How do you want to predict minor and major product? When double bond carbon atoms in alkene have substitution with one highly substituted over another, a mixture of major and minor products are formed. Example, 2-butene tadi yang kita buat tadi. The intermediates are secondary and tertiary carbocations. Because the most stable tertiary carbocation is formed more rapidly than less stable secondary carbocation, so the major product is produced from the tertiary carbocation. Okay, tak faham? Okay, apa? Okay, stability of carbocation. So how do you want to know produk mana akan jadi major, produk mana akan jadi minor product? Okay. In electrophilic addition to unsymmetrical alkene gives the more highly substituted carbocation intermediate because highly substituted carbocation forms faster than less substituted and rapidly goes to give the final product. Highly substituted carbocation is more stable due to inductive effect and hyperconjugation. Okay, so this is the stability of your carbocation. So methyl is less stable compared to primary, compared to secondary, compared to the tertiary. cation. So, bila kamu dapat tertiary cation, this is the most stable carbocation. So, produk ni akan menjadi major product compared to the rest of the carbocations. Okay. So, contohnya yang ni. 2-methyl 2-butane tadi. So, you have carbon 1, carbon 2, carbon 3 and carbon 4. So, your main focus is on your carbon 2 and 3. Okay. HBr nak masuk. So, according to Markovnikov's rule, H akan masuk kepada carbon 2 atau carbon 3. Okay, dia akan masuk kepada carbon 3. Sebab hidrogen akan masuk kepada carbon yang banyak hydrogen. So if you can see here, carbon 2, there's no hydrogen directly attached to this carbon 2. Whereas for your carbon 3, you have one hydrogen attached directly to this carbon. And your Br will masuk kat sini. Okay. Betul tak? Okay. Dan kamu tengok. Katakanlah. Contohnya reaction yang ni lah. Kita dah tahu this will become your major product. So this is your major product. Br di carbon yang kedua. Mana? Okay. Br akan berada di carbon yang kedua. So this is your major product. Okay. So macam mana nak tengok? Kan dia dah cakap tadi. Tertiary carbocation is more stable compared to the secondary to the primary. So kamu tengok kat sini. Double bond ni akan terbuka. H akan masuk dekat sini kan. So bila H masuk kat sini, ini akan jadi carbocation. Positive charge kat sini. Okay, kita tengok yang ni. Sebab kita tengok yang major compound. So H akan, double bond akan attach H kat sini. So H akan masuk kat sini. Sebab H akan pergi kepada carbon yang banyak H. So yang kat sini akan jadi carbocation. So if you can see here, this is your tertiary carbocation. 1, 2, 3. Ada 3 jiran kat sini. So it become a tertiary carbocations. Okay, whereas if let's say lah, kamu nak masukkan hydrogen kepada carbon kedua. So this is your carbon 2. So this will become your carbocation. So this is only a secondary carbocation. So dia ada attachment kepada 2 carbon saja jiran dia. So secondary cation. So tertiary cation is more stable compared to your secondary carbocation. So that's why tertiary will become a major product compared to secondary akan jadi minor product sahaja. Okay. So sama juga kita dah tahu. H akan masuk kepada hydrogen yang banyak. Cl akan masuk kepada X akan masuk kepada yang banyak substituted alkyl kat situ. Both ways, you can look at it at both ways lah. Both ways. It's either you want to look at the hydrogen. Hydrogen akan cari kepada hydrogen yang carbon yang banyak hydrogen, ataupun kamu nak tengok in terms of Cl. Yang X tadi. So X akan pergi cari carbon yang banyak alkyl group kat dia. So both ways, you can look at both ways lah. Hydrogen boleh tengok, kepada X pun boleh tengok. So the same case here. So Ki ni akan react dengan H3PO. So dia akan hasilkan Hi. So Hi ni double bond akan pergi attack hydrogen. So hydrogen akan masuk dekat mana? So hydrogen akan pergi dekat carbon yang banyak hydrogen. So hydrogen akan pergi sini, I akan masuk sini. And some more, you see. Katakanlah hydrogen masuk kat sini. So yang ni akan jadi positif kat sini, carbocation ni kan. So this is a secondary carbocation. Secondary carbocation. Tapi katakanlah kamu nak masukkan H dekat sini. Katakan kamu masukkan H dekat sini. Menyebabkan karbon pertama ni akan jadi carbocation dekat dia. Bila kamu tengok dekat sini, if you put a carbocation here, so ini ialah carbocation primary, which is less reactive compare your second. So cannot be lah. So your secondary carbocation has to be a major product compared to primary carbocation. Okay, contoh addition of HBr in solvent to 1 pentane. So satu pentane. So this is your double bond. H kat sini. So H akan pergi ke karbon 1, karbon 2. Dia akan pergi ke mana? So H akan pergi ke karbon pertama sebab H akan pergi kepada C yang banyak H. So Br akan masuk kepada karbon kedua. So this is your major compound when your Br is at second carbon. Kalau dia masuk kepada yang first carbon bromine, so dia akan jadi minor product. Cuba buat dia punya carbocation, then you will see that this will become a primary carbocation, this will become secondary carbocation. So secondary lebih stable compared to the primary carbocation. Okay, ini mekanisme. Saya rasa bila kamu faham mekanisme baru nampak kenapa H tu akan masuk ke situ ke Br masuk ke mana ke. Okay. So mechanism of halogenation of 1 pentane contoh tadi. Step 1. Double bond alkene nucleophile. Sebab this is full of electron kat sini kan double bond. So double bond will attack H electrophile kat sini. So double bond akan attack H. Ni akan terputus. So H kat sini akan masuk ke mana? From HBr to form CH bond. This leaves the other carbon with a positive charge, carbocation. So H ni there are two possibilities. H boleh masuk kat karbon 1 atau H akan masuk karbon 2. So there are two possibilities. Buat dua-dua. So let's say if you want to add in your hydrogen into carbon 2, so ni jadi akan produk dia. Akan produk dia intermediate. This is only the intermediate first. Okay, step 1. So, bila kamu masukkan hydrogen kepada carbon kedua, sini carbon 2, this is carbon 2, this is carbon 1. If you want to insert your hydrogen at carbon 2, so this will become the carbocation. This is a primary carbocation. Okay, tapi katakan kalau kamu nak letak hydrogen pada carbon pertama, ni hydrogen pada carbon pertama, so ini akan jadi secondary carbocation. So this will become secondary lebih stable compare dengan primary. So this secondary carbocation will be your major intermediate. Dan satu lagi, kalau tengok hukum Markovnikov tadi, Markovnikov says that hydrogen will go to the carbon with more hydrogen. So hydrogen akan masuk kat sini. Sure enough. So hydrogen akan masuk kat sini. It will make a secondary carbocation which make it is a major intermediate. So betul lah apa Markovnikov cakap. Okay, step 2. Dia dah jadi carbocation. Bromide ion pula nucleophile akan pergi serang negatif, akan pergi serang carbocation ion ni. So dia akan attach ke situ. So if this is your primary carbocation ion, so bromo akan berada pada satu bromo. This is your product lah nanti. So tapi katakanlah secondary carbocation ion, bromo akan masuk kat situ. So ni akan jadi final product, dia akan jadi 2 bromo. So kita dah tahu this is secondary carbocation ion is much reactive compared to the primary. So secondary carbocation ion akan convert menjadi major product. So contoh lain, ini contoh lain, bukan contoh. Okay, 2 pentane pula. Contoh untuk 2 pentane. Okay. Okay, when both double bond carbon atoms have the same degree of substitution, addition of HBr to 2 pentane is not regioselective. So positional dia, kamu ubah mana-mana pun dia akan sama. Okay. 2 carbon intermediates have same stability. A mixture of addition products will be formed. Macam tadi minor dengan minor dengan major product kan. So major product mungkin 99% is the product. Ini mungkin hanya 1% produced by end of the reaction. Tapi kalau yang ni mungkin 50%, yang ni 2 bromo dan 50% juga untuk 3 bromo. But dia tak regioselective. A mixture of addition products will be formed. So contoh mekanisme yang sama. H akan pergi kepada H yang banyak. So in this case, in 2 pentene, tengok carbon ni. Carbon 1, carbon 2, carbon 3. So this is your double bond. H akan masuk kepada carbon yang banyak H. Saya sekarang, dua-dua carbon ni ada satu H each. So dia akan pergi ke mana? Dia boleh pergi mana-mana sebab syarat dia sama saja dua-dua tu. Okay. So dia akan masuklah mana-mana yang nak pergi. Either dia boleh masuk karbon ketiga ataupun dia boleh masuk karbon kedua H tu. Sebab kalau kamu tengok, dua-dua akan jadi primary carbon saja. Primary carbon pula. Primary carbon pula. Dia akan jadi carbocation. Sorry, bukan primary. Secondary carbocation. Kalau kamu letak kat sini pun jadi secondary. Kamu letak kat sini pun jadi secondary. So dia balance. Have same stability. Intermediate carbocation dia sama. Secondary untuk dua-dua. So both have the possibility, both have the same percentage of stability to produce products. Okay, checkpoint. Cuba buat dulu. Okay. That is not it in your hydrohalogenation. Dah ikut dah syarat Markovnikov. Markovnikov cakap hidrogen akan pergi ke karbon yang banyak hidrogen ataupun X kamu halogen akan pergi ke karbon yang banyak alkyl substitution. Okay. So there's another another condition syarat that can make that can define what kind of products that you will get. Okay. Reaction HBr with 3-methyl 2-butene yields an unexpected of 2-bromo 2-methyl 2-bromo 2-methyl butane along with the expected product 2-bromo 3-methyl butane. Apa benda ni? Okay. So buka. This is your starting material. 1 butane. So ada 4 carbon. 1, 2, 3, 4. Double bond dekat sini. 1 butane. Lepas tu ada 3 methyl. So sini ada methyl dia. Okay. So dia cakap okay. Contohnya lah. Dia ada bromo kat sini kan. So maksudnya HBr akan masuk kat sini. Okay. Ikutkan Markovnikov cakap. So this is your double bond kat sini. So sini ada H2. Ini ada satu H kat sini. Okay. So Markovnikov cakap H akan pergi ke karbon mana? Sekarang karbon 1 ada 2 hidrogen, karbon 2 ada 1 hidrogen. So H akan pergi kepada karbon 2. Betul. So kita akan expect Br akan berada di sini. So kita akan expect yang kita akan ada 2 bromo as the major product. Kan? Tapi ni dia cakap kan reaction HBr with 3-methyl 1-butane yields an unexpected 2-bromo 2-methyl. Ini 2-bromo 3-methyl. Tapi yang ni cakap kat sini along with the expected product 2-bromo 3-methyl. Okay, this is the expected one according to Markovnikov rules. Tapi sekarang ni cakap unexpected 2-methyl 2-bromo 2-methyl. Macam mana bromin ni, bukan bromin. Macam mana methyl ni boleh bergerak kepada position 2 pula? Sedangkan asalan dia berada pada karbon 3. Okay. There's a rearrangement of your carbocation kat situ. Carbocations intermediate undergo structural rearrangement. Secondary carbocation rearranged to make a more stable tertiary carbocation by hydride shift. Maksudnya hidrogen tu akan bergerak. Dia shift hydride tu ialah hidrogen. the shift of a hydrogen atom and its electron pair between neighboring carbon. Okay, so tengok kat sini. Electrophilic addition reaction of alkenes. So this is your 3-methyl 1-butene tadi. Structure tadi sama. Okay, kamu tengok. Okay, fokus sekarang ialah dekat hydrogen yang purple ni. Okay, macam biasalah hydrogen akan masuk kepada mana? This is your double bond. We expect the hydrogen will go into your carbon 1 ke carbon 2. So H will goes to your carbon 1 as what Markovnikov says. Hydrogen akan pergi ke karbon yang lagi banyak hydrogen. Carbon 1 ada 2 hydrogen, carbon 2 ada 1 hydrogen. So H akan pergi masuk kepada carbon 1. So H masuk carbon 1 menyebabkan carbon 2 akan jadi carbocation. Okay, ni faham kan? Okay, sekarang this is your secondary carbocation. Sebab ni carbon positif ada kat sini, dia attach directly kepada dua jiran. So so dia akan jadi secondary carbocation. Okay, kamu tengok sekarang. Let's say lah hydrogen ni yang purple ni, ini carbocation ni tukar tempat, shift. This is now a secondary. Katakanlah carbocation ni dia nak pindah kat sini. Okay, ni carbon ni carbon 1, ni carbon 2, carbon 3, carbon 4. Okey. Karbo ni, carbocation ni daripada position 2 dia nak pergi position 3. Kenapa dia nak berpindah? Dia nak pindah ni. Ni kan 2 kepada 3. So 2 kepada 3 dia dah berpindah ini. Ni hasil dia lah, perpindahan positif, charge positif kepada carbon 3, hydrogen kepada carbon 2. So this is the product. Kenapa dia nak pindah? Sebab daripada secondary dia boleh jadi tertiary carbocation, which is more stable compared to secondary. So dia shift dulu baru dia bentuk produk. Kalau dia tak shift, so this is the product. You will have a 2-bromo 3-methyl. Tapi kalau kamu shift, buat hydride shift kat sini, which you shift into a more stable carbocation, so you will have a 2-bromo 2-methyl instead. Okay, terus checkpoint. Checkpoint ada jawapan. Oh, write a mechanism. Okay, try lah buat. Okay, the final reaction of your alkene. Hydration. So, hydration ialah masukkan water dalam dia. Okay. Addition of H and OH groups from a water molecule to a double bond will produce an alcohol. The reaction is facilitated by use an acid as a catalyst. So, this is your acid catalyst kamu. So acid akan masuk kepada double bond alkene ni. Will convert alkene to alcohol. Okay. For unsymmetrical alkenes such as butene, the hydration reaction follows Markovnikov rule. Rich gets richer. So hydrogen akan masuk kepada carbon yang banyak hydrogen. So you can assume ni water ni, macam ni structure dia. H, satu lompat kat sini. So H ni, one of the H will goes to this carbon. Carbon 1, carbon 2. Kenapa dia masuk carbon 1? Sebab H akan pergi kepada carbon yang banyak H. Carbon 1 ada 2 H, carbon 2 ada 1 H saja. So the first H will goes into your carbon 1 sebab ada 2 H kat situ. So OH akan masuk dekat carbon 2 nanti. So this is the same, it follows the same Markovnikov rules juga. So dia akan produce 2 butanol kat situ. Okay, apa mekanisme dia? The first step, double bond, macam biasalah, ni kan negatif, akan pergi serang H ni. Double bond alkene nucleophile attacks H, electrophile from acid, forming new CH bond and leaves carbon atom with a positive charge, carbocation. So bila ni attack, double bond akan terbuka, H akan masuk kat sini. Sini akan jadi carbocation sebab double bond dah terbuka kat situ. So this is the first step of your reaction. A carbocation, secondary carbocation. Okay, proton transfer from hydronium to alkene. Ni proton ni transfer. Ini sebiji ni, seketul ni saja yang akan masuk dalam alkene tu. So the rest yang ni akan jadi water balik. Ni water balik kat sini. Okay, second step. Water molecule yang tadi, water molecule tadi tu, nucleophile donates an electron pair to the carbocation forming CO bond, resulting in positive charge on oxygen protonated alcohol. So the whole thing get attached dekat si carbocation ni. Non pair ni akan buat attachment kepada carbocation. So dia jadi macam ni. The whole thing ni. So the whole thing ni nama dia adalah oxonium ion. Reaction of the carbocation, ni carbocation the whole thing, with water nucleophile gives an oxonium ion. So ini intermediate saja, belum jadi final product. Okay, step 3. Water molecule ni, sebiji lagi water molecule pergi tarik hidrogen kat sini. So bila tarik hidrogen kat sini, OH akan kekal kat sini, H akan jadi H3O plus balik. Nah, situ. Okay, proton transfer to water gives an alcohol. So, H dah belah kat situ, OH akan ke kat sini menjadikan dia alkohol. Okay, checkpoint, try buat.